So here are the answers to these questions, and I know a couple of them. I think especially 9 and 10 are a little bit beyond what we went over in class already, but freeze the screen, see if you can get these answers. If you can't, I am only going to go over number 4, 6, 9, and 10 for the rest of this video, so if you have questions about any of the other ones, bring them to class. So here's number 4. D is 1/2 AT squared, and you're solving for t. You were told to solve for t. So you want to get t by itself on one side of the equal sign, and you see that it's squared, but we're going to take care of that last. What we're going to do is move things over until only t squared is left, and then we'll take a square root and get rid of that. So the first thing, let's get rid of this fraction, this 1/2. So I can divide by 1/2 if I want and end up with d over 1/2, but I'd rather not have the fraction in the denominator of another fraction if I can help it. So I'm going to multiply both sides by 2. I'll write 2 over 1 so you can see what's happening. And remember, you don't distribute across multiplication. So I wouldn't multiply the 2 times the 1/2 and then times the a and then times the t squared. I multiply by the whole thing. So I have, I can just look at this as 1/2 times 2. I get 2 over 2 here, and that is 1, and I don't have to write it. So that gets rid of this. But whatever I do to one side of the equation, I have to do to the other. So I get 2d equals at squared. And how do I get rid of multiplying by a? I would divide by a. So I'll divide both sides by a. A over a is not 0. A over a is 1. So I end up with 1 times t squared, which I can just write as t squared equals 2d over a. And the last thing I need to do is get rid of taking the square root. Or I'm sorry, is get rid of squaring t, which I would do by taking the square root. The square root of t squared is t. And if whatever I do to one side, I have to do to the other. And so I would end up with t equals 2d over a. And I mentioned in class, and it's worth mentioning again, that make sure you put the, I will take points off your paper if you only put the radical over the numerator, for example. So if you gave me an answer that looked like this, I would take points off. Even if you ended up doing the arithmetic correctly, I would take points off. This and this are not the same. They are not equal. Even if you did something sort of casually like this and I couldn't tell where it was, I would take points off. So make sure your radical goes over the entire fraction. What it might be helpful to do is to write down what's under the radical first and put in the radical last to make sure that it covers the whole thing. But make sure you do that if you want to get full credit. I am a little bit of a stickler about that. Here is number 6. You're given v equals the square root of 2ad, and you're asked to isolate d. So the first thing you want to do, since d is under a radical on this whole side of the equal sign, is you want to square both sides of the equation. So let me get a different color here. You want to square this, and you want to square this. Well, v squared is just v squared, and the square root of 2ad squared is 2ad. So that's what happens when I square those. When I square this, I just get rid of this radical here. And I want d by itself, so it's being multiplied by 2a. I can divide it by 2a. 2a over 2a is 1. Any number divided by itself is 1, so I end up with 1 times d, and I don't have to write 1. So I end up with d equals v squared over 2a, and that is my answer. And here's number 9. T equals 2 pi over the square root of L divided by G. So this whole thing's under the square root, and you're asked to solve for G. So this is kind of a pain, right? So what I know I have to do is get rid of this radical. G is under a radical. It's under, I'm taking the square root of 1 over G here, or L over G. And so I need to get rid of it. So what I'm going to do is square both sides. Now when I square this side, the right side of the equal sign here, I can't just square the L over G. I have to square every single term. And we know that T, that's easy. I'll just square that T. So I end up with T squared equals, I have to square the 2. I have to square the pi, and then I have to square the square root of L over G. So 2 squared I know is 4. Pi squared is pi squared. And then when I take the square root of L over G or I'm sorry, when I square the square root of L over G, I end up with L over G. And remember, this 4 pi squared is just, I could multiply, I could write this as the entire numerator of this fraction. It's the same thing. These things are equal. So L over G doesn't have to stay separate because it's being multiplied. When you multiply something by a fraction, it really is just multiplied by the numerator, not the denominator. So how do I get G by itself? Let me write this over down here. I end up with T squared equals 4 pi squared L over G. First step is to get G out of the denominator. So I'm going to multiply both sides by G. I'll write G over 1 so you don't get messed up. And G times G, or I'm sorry, G divided by G is 1. I don't have to write that, so this would be 4 times pi squared times L times 1, but I don't have to write that. But since I did that to the right side of the equal sign, I have to do it on the left side. So I end up with G times T squared equals 4 pi squared L. And I want to solve for G, so I'm going to divide both sides by T squared. T squared over T squared is 1. Any number divided by itself is 1. So I end up with G equals 4 pi squared L over T squared. And that is your answer. So here's a problem. We're going to solve it two ways, but I am asked to solve for d sub I, this di here. And it's in the denominator of a fraction, but I see that everything here is a fraction. What some students do with this, that is completely wrong, is rewrite this and they figure, well, since everything's being divided into 1, this is the same as this. And this is wrong. What I'm writing now is completely wrong. This is wrong, 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 wrong. You cannot do that. So these are fractions. And, you know, 1 half equals 1/4 plus 1/4 is not the same as saying, right? Let me write that. 1/2 equals 1/4 plus 1/4, which it does not translate to 2 equals 4 plus 4, right? That doesn't make any sense. So one of the strategies you use, I don't remember all my math rules. So one of the strategies you can use if you're saying, well, gee, I wonder if it's okay to do this, is to put in real numbers. I know that if I have a quarter plus a quarter, I end up with a half, right? There's quarters. If I take 1/4 plus 1/4, I end up with a half. And I know that that's true. But then it does not follow that 2 would equal 4 plus 4. That's not correct. So there's no shame. Your math teachers may think differently, but there's no shame in kind of forgetting some of your math rules. But remember, you can always make up numbers and pick easy numbers, but never pick one. You can always make up numbers and see if it works, if what you're doing really preserves this equality, if it keeps things equal, and if it doesn't, then what you're doing is wrong. So check your work. So let's undo all of this and let's take a look at this equation and let's try to see how we can solve for di. So the strategy we've been using when our unknown has been in a denominator is to multiply by that variable to get it out of the denominator and into a numerator. So let's try that. I'm solving for di. So again, I'm going to show you two ways to solve this. The first way I don't think is, well, either way works. I don't care. So we're going to multiply by di. I'm going to write di over 1 so that I don't get messed up. And now we'll go through, and remember I have to distribute this. I have to multiply by every single term. So di times 1 over f, I get di over f equals di times 1 over do would be di over do. Di times 1 over di would give me di over di, which is 1. So when I multiply di times every term, this is what I get. I want to solve for di, so a strategy for doing that is to get all the terms with a di in them on the same side of an equal sign. So what I would do is I would subtract di over do from both sides. And so di over do minus di over do is 0. So I end up with just 1 on this side. And on this side, I end up with di over f minus di over do equals 1. So we're getting there. Now I want to factor out that term, my unknown here. I want to factor out di. So how would I do that? I could write di is 1 over f minus 1 over do, and that equals 1. And I can see that if I multiply this back in, right, when I'm multiplying into a fraction, this is the same as di over 1, I would end up with di over f minus di over do. I would end up with this thing right back. So these are equal. So this is, I just factored that out. Now I want di by itself. So how do I get di by itself? I'm going to divide out this expression in parentheses here, and it's quite an expression, but let me divide it out. 1 over f minus 1 over do. And this is just a product, di times this thing in parentheses. So if I divide by this thing in parentheses, even though it looks like a big mess, it really just is 1. 1 over f minus 1 over do divided by 1 over f minus 1 over do is 1, just like 5 over 5 is 1. But whatever I do to this side, I have to do to this side. So I would end up with di equals 1 divided by 1 over f minus 1 over do. And that's correct. It's not the nicest looking answer, but that would be correct. And now I'll show you a different way to do it. You would also get the correct answer, but it would look slightly different. So same problem, we're going to get a solution that looks a little different, that hopefully looks a little bit not quite so ugly. So what I'm going to do here is I'm going to get rid of all the denominators at once. So how can I do that? I'm going to multiply. I'm going to take every term in the denominator, f, do, and di, and I'm going to multiply every term by those. So I'm going to multiply everything by this, f times do times di, and I'll put it over 1 so you can see what's happening. And I'm going to write out these steps too so you can see what's happening. So I would have f do di over f equals f do di over do. I'm just multiplying this in. So I'm multiplying this by this and by this and by this. That's all I'm doing. So I'm distributing it in there, plus f do times di over di. So what do I get to do here? Well, here I end up with f over f, which is 1. And so I can cross that out. Here's do over do, which is 1, and here's di over di, which is 1. So I can rewrite this as do di equals f di plus f do. And this is a lot of baggage to carry around an equation, but this is how you do it. So I want to solve for di, which means I want to get all my terms with di on the same side of the equal sign. So I have one term with di here, I have one term with di here. I'm going to subtract this. I'm going to subtract my f di from both sides. And f di minus f di is 0. So 0 plus f do is just f do. I don't have to write that 0. So I end up with do di minus f di equals f do. It's ugly, I know. Now what I'm going to do is factor out. I want to solve for di, so I have to factor this out. I'm trying to get this by itself on one side of the equal sign, so I've got to factor it out. So if I factor out a di, I end up with do minus f equals f times do. And now all I have to do is divide out that expression in parentheses, that do minus f. Get a different color here. do minus f divided by do minus f is 1. So I end up with di times 1, and I don't have to write that 1, equals f times do over do minus f. So again, not pretty, but it is the answer. And this is equal to what I wrote in that first solution of the problem, so you could express it either way. So that's why sometimes in these problems you'll get something different from what's on the answer sheet, and you'll say, geez, did I do it wrong? Maybe you didn't. So you may have just expressed it differently. There's a lot of ways to express this that are correct. So if you have any questions on this or any of the other problems, bring them to class.